Okay, back to it. We were in the process of developing a way of taking the derivative of functions. Remember, our overall goal was to find, if we're dealing with f of g of x, what is the derivative of that? For now, we don't know. But what we have discovered is if we think of the g of x part, if we thought of that as u, we realize that we have to take the derivative of y with respect to u. And this is why I really want this notation to be a part of your thought process. And then afterwards, we have to respect the fact that u might change with respect to x. So a change in x causes a change in this inner function, and a change in that change in this last piece of the function causes a change to the function y itself. So dy dx is equal to dy du times du dx. In terms of this functional notation f of g of x, we could equivalently write that expression as f prime of g of x times g prime of x. And if you're thinking, what the heck? What that means is, in this case, it's like just take the derivative of whatever this thing is, really not considering what's in there. And then afterwards, consider the fact that that innermost function might be changing as well. So in the context of this, it would be, just like we wrote here, ignore this, 2, stuff to the first. Okay, now I've just said stuff to the first, as if that stuff was whatever I wanted it to be. But it's not whatever I want it to be, it's 3x plus 1. So we then have to take the rate of change of the 3x plus 1, and that's where this g prime comes in. And I made a little remember this box on the PDF. What I'm thinking in the remember this is take the derivative of the whole thing and then take the derivative of the inside. Now those are very loose terminologies, and that's why I developed a much more specific and rigorous way of stating it here and here. But what I mean by the derivative of the whole thing is just ignoring the inner function, 2 times something to the first. Then times the derivative of the inside, that examines the innermost function that we've named g of x. Okay, so now let's do a bunch of examples. What I really want you to think about, though, is that this isn't just some other rule that a bunch of dorks are imposing on you, even though that's the case too. I want you to think, why is it that we are taking the rate of change twice, effectively? What's that all about? And really think about that. Don't just say like, all right, whatever, just like do some problems, man. Like, as long as I have some problems, I'm cool, and I'll just do more of whatever you said until I just understand the how. It's just as important, especially at the early stages of calculus, to understand why, or 6 months from now, you'll be tied up in this whole thing and you won't remember what the heck you're doing. So, just going to pick a couple from that page that I put, that PDF that I posted. So this is the first one. The derivative, again, depending on how you want to think about it, you could, for example, think of this for yourself as 3u to the 5th and apply the first way of thinking, which would be 15u to the 4th du dx, where you go back and take the derivative of u with respect to x. I'm actually going to flesh that out a little bit more, and then I'll go through it a little bit more quickly with less noting. So where u is equal to x squared plus 1. So the derivative of this would be 15u to the 4th du dx. So now a little side calculation over here is, what is du dx? Well, derivative of u with respect to x is just 2x. So this would be 15 u to the 4th, that's x squared plus 1 to the 4th, times 2x, also known as 30x x squared plus 1 to the 4th. Now I know, you might think to yourself, again, this is a little bit too much detail here, but what I'm trying to do is really lay a solid foundation of notation. Now, if we do the same process very quickly, 3 stuff to the 5th. That must be 15 stuff to the 4th times the derivative of the inside stuff, which is, of course, this. Same result. Okay, let's do, how about halfway down the page, that one, -7 over 2t minus 3 squared. The first thing I would do is notice I did not write prime here. I'm leaving the original function. The first thing is I'm going to do that, just do a quick rewrite on the function. Otherwise, by the way, we would have to apply a quotient rule. So I'm making it so that we can use the chain rule and the simple power rules here rather than going into the quotient rule. If you prefer the quotient rule, have at it. It certainly is viable. So this would now be, pretend that's u or whatever you like. It'll be 14, positive 14. 2t minus 3 to the -3 times 2, which is 28 over 2t minus 3 cubed. Okay, and let's do the last two. And it might be a good idea, you know, I don't know what kind of habit you're in when watching these videos, but my ideal process here would be that if you see a problem go up here, you're hitting pause, you're working through it, you're seeing if you can get it, and then you use, you know, my explanation and my work here as a way to get you through it, if you could not. And when you have a paper like this, obviously just kind of follow through it and see if you can do them, and then use me as a checker. So we're going to do the second to last one there, which is sine of 3x squared, I believe. Let me check. Yes. So the derivative of that, this one's a little weird because it's not the typical power setup that you're used to. So think of that as our u value, sine of u. Well, sine of u. That's going to be cosine of u, right? Times du dx, 6x. And if you want to clean that up, I don't know if you prefer to write it like this. I certainly don't care. You get that. Okay, the last one I put on that page is what I call a double chain rule. This is not any kind of rigorous way of, you know, wording it or anything like that. But what I mean to say is that you have to apply the chain rule twice, because there are actually 3 functions going on here. You can think of this as, you know, g of h of k of x. And if you don't believe me, by looking at that, think about x. What happens to x when you throw it through this machine? First thing that happens is it gets quadrupled, multiplied by 4. Second thing that happens is sign gets taken of whatever that value is. Third thing that happens is it gets cubed. And it might not be apparent to you when you look at that just by seeing it like this. So sometimes, oftentimes, it is much more user-friendly for students to think about it as that, sine of 4x cubed, because we're about to take its derivative. So the first thing we need to do is figure out what is our our outermost function, and we determined that was the cubic. So we're cubing, so it's 3 times this stuff squared. Now we go inside and we say, what were we ignoring? And that was sine of 4x. Sine of 4x separately, his derivative, would be cosine of 4x. But again, we've ignored that inside part, the 4x. So now we have to multiply by 4. So there are 2 chains here. We've got 3 stuff squared, then cosine, and then we have to multiply by the linear factor of 4. And then you could clean that up if you wanted to, make it 12 sine 4x squared times cosine 4x. It doesn't really matter to me, whatever would be more useful in the context of the question. And that is that. Thank you.